Hello. No, fine. What are you doing? C plus plus. Okay, it's okay. Networking no. CCNA no. Okay, fine. Now, at this scenario, you all have done practice. Okay, fine. Now, at the same scenario, we can implement OSPF also, because I have already guided you about the concept of OSPF. Now, finally, we have to implement at the same scenario. You don't have your laptop? Have you? No. No. You both can join here. Please come. Why? You have mine. Okay, fine. Now just see. We will use the same scenario again, like this, and this. Same IP configuration, 11, 12, 10, 172.16, and 192.168.0. I have written network part on. Okay. At this scenario, you have done routing with static default RIP. Now OSPF. Fine. Look, as per theoretical concept, just I am repeating a few important points about OSPF. OSPF, first of all, is the open standard. Open standard means it can be used at any vendor router. Any vendor router means different company router. Fine. And OSPF can support a very large network. That network can be worldwide also. Okay. OSPF supports classless IP routing. Classless IP routing means a default series of IP address can be divided into multiple subnets, and these subnets can be of different size. Means these subnets can be based on DLSM. So if you will divide a default network series in different subnets, in that case, this kind of IP format can also be supported by OSPF. So in brief, we say OSPF supports classless IP routing. OSPF works on Dijkstra algorithm. OSPF uses the shortest path first technique, by which it can search best route from source to destination network. And OSPF works on bandwidth. It doesn't count hops or other metrics. It works on bandwidth. And due to this bandwidth calculation of link, it is known as linked state routing protocol. It sends triggered update Triggered update means whenever any change occurs, it will send the update to other routers. Fine. Now, next point is the OSPF uses a process ID that identify a particular router OSPF process. With the help of this process ID, an admin can identify all updates, all activities of a OSPF configured router. Fine. So we have to just mention it at the time of configuration of OSPF routing protocol. And one more important thing is that OSPF uses wildcard mask. Wildcard mask. Simply, we can say wildcard mask is just opposite of subnet mask. For example, if for this network is suppose 10.0.0.0, then its default subnet mask value is 255.0.0.0. Then wildcard mask will be opposite of this subnet mask, means in place of 255 we have to write 0, and in place of 0 we have to write 255. Then the value will be just 0.255.255.255. Correct. Actually, in this wildcard mask, we change the value of network bit and host bit. Actually, network bits are represented by 1 and host bits are represented by 0. We have to just change 1 into 0 and 0 into 1. Then the value of wildcard mask for this network will be 0.255.255.255. Fine. But fact behind it is that wildcard mask is used for summarization of the route, because OSPF doesn't support auto summarization of the route. It does not summarize multiple network information into a single route. So if admin has to give single route information to OSPF, in that case, admin can use this wildcard mask. Fine. Now, how we will configure OSPF for this scenario, for this network? Just I'm going to write down the steps. You all have to perform this thing right now. Basic configuration done. You all have configured your 3 routers, host in your scenario. Fine. And as I remember in last class, you all have configured RIP version 2 or RIP. So you have just to remove RIPs from routers. Like for removal of RIP, you have just, for example, I'm writing here. Router 1 configuration mode. At configuration mode, just write no router RIP. Fine. In this way, you will remove RIP routing protocol. Now your first router is without any routing. Then next, right, router OSPF. Now, routing protocol is changed. Then a specified process ID. You can take any process ID because its range is 0 to 65,535. Now I'm going to use, for example, 1 for first router 1, for second router 2, or third router 3. It can be any number from the range, but I have just taken 3 consequence number because it will be easy for us to remember. Router OSPF 1, then as we have used in case of RIP, we have to specify the connected network information only. So network 10.0.0.0. Second network is 11.0.0.0. We have used these two steps in case of RIP protocol. But in OSPF, we have to add some more information with these network information. Which information? Look, network 10.0.0.0. After that, we have to write here wildcard mask. Wildcard mask. Then the wildcard mask will be 0.255.255.255. Same in next step, 0.255.255.255. Now, OSPF supports a very large network. So OSPF also uses a technique by which it can divide a large network into multiple segments. And these segments are known as area. These segments are known as area. We can use different area, but right now I am going to use only a single area, that will be 0. And this area will be known as backbone area. Backbone area, area 0. So right here, area 0. Area 0. Fine. Configuration done. Now at router 2, configuration mode. Again, if you have already configured RIP version 2, just remove it. If not, then directly you can write command router OSPF process ID 2. Now network 172.16.0.0. Wildcard mask will be 0.0.255.255. Again, area is 0 because we have decided that we have to keep the same area at all routers. Now, next network is 11.0.0.0 and its wildcard mask will be 0.255.255.255 and again area is 0. Now, next network 12.0.0.0 0.255.255.255 area 0. At router 2 we have done OSPF configuration. Now at router 3, configuration mode, router OSPF process ID 3, network 192.168.0.0, 0.0.0.255, again area 0. Second network information 12.0.0.0, 0.255.255.255 area 0. Fine. This is only the configuration part of your OSPF. One, two, three. These numbers are process ID of routing. Yes, routers, routing protocol OSPF. Area value is used for grouping of OSPF routers. Now, suppose these 3 routers are in the same area because I have used value 0 at every router. If all these routers in the same area, in that case, these routers will send every information to each other. Every information. But if we will divide it into multiple areas, in that case, one area router will transfer only final routing table update to next area. So it helps routers to reduce reduce traffic load, extra processing. So anything which can support a very large network, all those things must have those techniques by which it can reduce extra works for fast searching of route, for fast transmission of data, right? It is similar, like suppose I have just to manage my room. It's okay, I can do work in any way. But suppose you have got a task that you have to manage the complete hostel room. Fine, and there are 100 rooms in the hostel. Then you have to make some plan. And as per the plan, if you will do, then you will be able to handle all rooms of your hostel. Simple. If there is too many tasks, that is there should have many items. OSPF supports a very large network to handle these large networks. OSPF, it can manage a large network. So OSPF divides routers, OSPF configured routers into multiple groups, and these groups are defined with a value of area. And area value range is 0 to 4.2 billion. Yes. Correct? I think you all have noted down. No. Yes. Because the subnet mask of class C network, default subnet mask is 255.255.255.6, and opposite of this value will be 0 becomes 255 becomes 0, 255 becomes 0, 255 becomes 0, and 0 becomes 255.
Totally opposite.
Totally. Sorry? Just do it. It will take hardly 5 minutes. Then do it again. Anyone but 4.2 billion. Yes.
Sir, what is the difference between Process ID and router ID.
Process ID and router ID.
Both are same.
No, both are different. Both are different. Process ID is used only to identify process of a router, but router ID is used for DR and BDR election.
Obviously, in recognition, ID and or this will be done for different.
You have done OSPF configuration. Yes. Okay, if you have done, it's good. Look, you should come and sit beside. Sit beside. Right now, you are creating scenario. Sorry. Is it okay? Huh? What happened? No, this is not using that. You are using, have you configured this IP address 10.0.0.65?
No.
Okay, fine. One 192.168.0.1. On the serial interface, there is no IP address at serial interface. So at configuration mode and INT serial 0/0/0, then IP address 12.0.0.2, 255.0.0.0, 0. That's it. No shut. Fine, configuration done. At first router, just check what have you configured. You have already configured remove RIP and router OSPF1 network 8-bit. Okay, good.
I think
No, it's good. 10. Yes, it is. You have given a space. A space will be required here.
there is no space. There is a point.
Look, 10.0.0. And at second router, 172, 11 and 12, all correct. Yes, this information shows that you have properly configured router 1 and router 2 because routing table done. Routing table loading done. Okay, loading done. See, loading done. Okay. And at router 3, router 3, 192, okay, fine. At this router also, loading done. Finally, just check at router 3 that routing table has all network information or not. So to show IP route, yes, it has 10 network information. Once all network information are available, 10, 11, 12, 172, 192, 1, 2, 3, 4, 5. So why are you confused? You are surprised that still you are configuring. Now see. Just look at the board. I think few students have lost their last configuration. Okay. Now, in the same scenario, we can use differently. Just then, what types of changes are required? Just think. We will keep this router in area 1. This router in area 0. Fine. Then it is okay. Now, at router 2, if you have chosen area 1 for this interface, then this interface should also be in area 0, because here area 0, that's why it will be in area 0. And now this is in area 1, that's why it will be in area 1. Fine. So at second router 11.0.0, in this line we have just to make a change like remove 0 and put 1. Sorry, 0. It is correct. Okay. Just here, remove 0 and put 1. Now, the condition of this interface is just like pendulum. Where should I go? In area 0 or in area 1? So you can keep it in area. So decide area 0 or area 1? 0. Okay, you all have decided 0. So fine, 0 is okay. And now at router 3, we have decided this router will be completely in area 0. Sorry, area 1. So we have to change area 0 to area 1 and area 0 to area. Fine. Now, this router is completely in area 0. This router is completely in area 1, and this router is now area 0 and 1. So if any router has 2 or more than 2 area, in that case, this type of router is known as ABR. ABR, area border router. So now a router 2 is ABR. Now what is the function of ABR? ABR is able to establish connection between 2 or more different areas. So now, only route information, routing table update of this network will be transferred to this network. And who will be responsible to transfer only routing table update? This ABR router. And the same way, this router network information or routing table information will be transferred to this router. But who will help? Who will help for this router? Again, ABR. As per the concept, ABR only transfer routing table updates from one area to another area to reduce extra work, extra processing tasks. Fine. So this is your homework. you have to configure uh, uh, the changes at the same setup. Okay, so just note down it. Till that, I'm going to mark your attendance. Okay.